Question 79. Consider the sequence 4-8. If this sequence is arithmetic, write the first four terms and an equation in, quote, first term form for t of n. Well, if this is indeed arithmetic, my first four terms, and I guess this is part A, my first four terms would be I'd have a 4, and then I would go to 8. And if it's arithmetic, what I'm doing each time is I'm adding 4. So the next one, I would 8 plus 4 more would give me 12, and 12 plus 4 more would give me 16. So those are my first four terms. Now, if I wrote this as just an equation, not in first term form, it would be y equals, let's see, my slope is my common increase of 4 each time, 4x plus I start at the number 4. So that's the equation, right? That's not first term form. If I put in x is 0, that generates 4. If I put in x is 1, it generates the 8. So this is what it is an equation. In first term form, there's just one modification we make, right? First of all, we're going to use function notation. So we say the value of the nth term is equal to, and we're going to write 4 times the quantity of n minus 1. So you can see I'm just replacing x with n minus 1, and then I'm going to add to that the value 4. And just to verify, see what's happening here with this, if n is 0, I place a 0 in, not 0. If n is 1, I would want to know what the first term is. If n is 1, to find the first term, I would put a 1 right here, and it becomes 1 minus 1 times 4, which is just 0. So this becomes 0 plus 4, which is my 4. So you can see when I plug 1 into my input for this function, it produces the value it should produce first, the value of 4. So that's question B. I have the whole thing in first term form, and I have the first 4 members of that sequence. So we're still considering the same sequence. B says, if the sequence is geometric, write the first 4 terms, and also an equation in, quote, first term form for t of n, the function t of n. So for B, if I was going to write down the first 4 terms, the first one would be 4, and then I go to 8. But what I'm doing now is I'm not adding 4 each time. If it's arithmetic, I'm doubling. So when I double 8, I'm at 16, and when I double again, I'm at 32. So there's my first 4 terms if this is an arithmetic sequence. Now if I was to write this as an equation in not first term form, just the equation, right? It would be y equals, remember the form is a times b to the x, where a is your first value and b is your common ratio, right? Going up by 2 each time. So this one should be 4, oops, go back over here. This should be 4 times 2 to the x power. Now if I want to flip this and make this in first term form, here's the only modification that happens, I think. I think it becomes, it's a sequence. N is the term number that I want, and t is the function that generates that term number. And I have that equals, it's still a 4 times 2. And then instead of writing x, I'm going to write to the n minus 1 power. And again, just to take a look at this, if n is 1, if I want to know what my first term is, I would place 1 into the function here. 1 minus 1 is 0, so this becomes 4 times 2 to the 0 power. 2 to the 0 power equals 1. 4 times 1 is 1. So this definitely generates the correct value. Now C is a really interesting question. It says create another sequence that is neither arithmetic nor geometric and still starts with 4 and 8. And I have no idea what I'm going to do with this. I've got the 4 and then the 8. Let's see, what can I do next? Well, and that's really the point, isn't it? Your solution has to be your solution. It has to be something that you think of. And, you know, I can show you things that I'm thinking of. You know, for example, I might think of something like 4 times. I can't think of anything. That'll be fun. I can't wait to see what you guys have for answers to that question. And then I'll write them down and maybe I'll talk about those next year.